Bill Binder's business nearly went under when Colorado almost passed the bottle bill. Binder's Beverage produced soft drinks for many of the large grocery stores in the area. After the bottle bill fell, Binder's Beverage flourished. In a few short years, the company had a major plant in Denver and a warehouse in East Denver. The problem was getting the finished product to the warehouse. Although Bill was not good with distance, he was good with times. Denver is a big city with numerous roads that can be taken from the plant to the warehouse. Figure below shows the road network. The soft drink plant is located at the corner of North Street and Columbina Street. High Street also intersects North Street and Columbina Street at the plant. 20 minutes due north of the plant on North Street is I-70, the major east-west highway in Denver. North Street intersects I-70 at exit 135. It takes 5 minutes driving east on I-70 to reach exit 136. This exit connects I-70 with High Street and 6th Avenue. 10 minutes east on I-70 is exit 137. This exit connects I-70 with Rose Street and South Avenue. From the plant, it takes 20 minutes on High Street, which goes in a northeast direction, to reach West Street. It takes another 20 minutes on High Street to reach I-70 and exit 136. It takes 30 minutes on Columbina Street to reach West Street from the plant. Columbina Street travels east and slightly north. West Street travels east and west. From High Street, it takes 15 minutes to get to 6th Avenue on West Street. Columbina Street also comes into this intersection. From this intersection, it takes an additional 20 minutes on West Street to get to Rose Street, and it takes another 15 minutes to get to South Avenue. From exit 136 on 6th Avenue, it takes 5 minutes to get to West Street. 6th Avenue continues to Rose Street, requiring 25 minutes. 6th Avenue then goes directly to the warehouse.
Good morning. We are going to explain how to resolve the problem about Binder beverage case that it concerns about the short staff. In this case, we can say that Binder Beverage is a company that produces soft drinks that can be distributed in very large, numerous areas in Denver. That it is the city when is located the plant. The problem started with Binder Beverage needs to distribute its finished product to the warehouse, but there exist many routes and he doesn't know what is the optimal route or the optimal path that he has to take. We have the diagram of no directed nodes that shows all possible routes that the business can take. In this case, we have that in the node 1 we got the plant, and in the node 2 we have exit 135. We can appreciate that those nodes are connected through the North Street, and it takes 20 minutes. We also can see in the figure that the node 2 to the node 4, when we can appreciate the exit 136, those are connected and it takes 5 minutes. We also can see that the distance between the plant and the node 4, it takes 20 minutes and it is connected through the high street. And it also is connected the node 4 to the node 10 through the 6th Avenue Street, that it takes 5 minutes to the node 4 and the node 5, and to the node 5, from the node 5 to the node 6, 20 minutes, and from the node 6 to the node 10, 40 minutes. To the node 8, from the node 4 to the node 8, where we have the exit 137 through the street I-70, it takes 10 minutes. And the node 8 is connected with the node 10 through the South Avenue, and it takes from the node 8 to the node 9, 10 minutes, and from the node 8 to the node 10, 15 minutes. The other roads are more shorter than the other ones, and we can see that the node 3 to the node 5 takes 15 minutes, the node 5 to the node 7 takes 20 minutes, the node 5 to the node 6 takes 20 minutes too, and finally the node 1 to the node 5 takes 30 minutes, and those are connected through the Columbian Street.
Steps to find the shortest path. First, find the nearest node to the region. In this case, the plant. Place the distance in the box next to the node. Second, find the next node closest to the region or the plant and put the distance in the box next to the node. In some cases, several routes should be reviewed to find the nearest node. Third, repeat this process until the entire network has been checked. The last distance on the final node will be the distance of the shortest route. You should note that the distance placed in the box next to each node will be the distance of the shortest route to that node. Such distances are used as partial results to find the next nearest node. First, we have to set our mathematical model. For this, we are going to define the variables. We are going to say that x sub index ij is the flow on road from node I to j. Then we have a parameter that is going to be t sub index ij, that is the time it takes going from node I to j. Then we set our objective function. We are going to minimize c that equals sigma that goes from I equals 1 to then. Sigma that goes from j equals 1 to then. T sub index ij times x sub index ij. Now we set the constraints. Net flow from a starting node 1 is -1, and net flow to end node 10 is 1. For the rest of the nodes, net flow is 0. So the constraints are these.
To solve that problem in the Binder beverage, we are going to use the QM for Windows. The first part is the module tree, the high panel. We are going to choose a shortest route. The next thing that I choose is a network type, undirected. Remind that graph is undirected. Another thing is origin. We remind that problem have 10 nodes. Origin is 1 and the destination is 10. Bring the beverage have 16 branch. Start nodes, end nodes, and the time to record the start node to end node. The branch 1 have start node number 1 and end node number 2. The time is 20. The branch 2 is start node 1 and node 3 and time 20. The branch 3 have start node 1 and node 5 and time 30. The branch 4 have time nodes 1, 2, nodes 2 are 20 minutes. From node 1 to node 3 have 20 minutes. From node 1 to node 5 have 30 minutes. From node 2 to node 4 have 5 minutes. From node 3 to node 4 have 20 minutes. From node 3 to node 5 have 15 minutes. From node 4 to node 8 have 10 minutes. From node 4 to node 5 have 5 minutes. From node 5 to node 6 have 25 minutes. From node 5 to node 7 have 20 minutes. From node 6 to node 7 have 20 minutes. From node 6 to node 10 have 40 minutes. From node 7 to node 8 have 20 minutes. From node 7 to node 9 have 15 minutes. From node 8 to node 9 have 10 minutes. And finish to node 9 to node 10 have 15 minutes. The next part is that click in solve and it shows the solution. We are going to resolve that problem in Excel. First, use the formula in flow equal sum if s, the range if in column A from A2 to A17 semicolon. Oops, I mistake in F oh, I'm mistake again. F2 semicolon. The solution column is in C2 to C17 parentheses less sum if s in the column B2 from B2 to B17 semicolon. Again F2 is the node semicolon again. I forget in semicolon. The range is C2 to C17 parentheses and enter. That's the formula. And forget is the dollar sign in a range because the range don't move it. Is Q. Only change the F. If you note is F2, F3, 4, 5, 6, 7, 8, 9, 10, and 11. We are going to put a dollar sign in the C2 and C17. Okay, and enter. The result is 0 because don't have a solution. To drag and put it well that the column H. Yes. Okay, the next part is in meantime. Is another formula is equal sum product parenthesis column C from 2 and 17 semicolon column D to 2 from 2 to 17 and enter is 0 because don't have a result. And finished, we are going to use solver. In datos solver, and I'm so sorry, I forgot erase the cells. Erase. Okay, and now we are going to solve that problem. The objective is C19 for minimizar. Change variables C2 to C17. The constraints is the next. Flow to 11, put G and is equal. The constraint is column I and add. The another constraint is the solution. Remind I have to note the 1 and 0s. And in solver have an option that binary accept. And the solution method is GRG nonlinear solve. And solver found a solution. That click in aceptar and
Recommendation. Here, by referring to the figure given in the book and consider the shortest path problem of binder beverage problem of transporting finished plant from plant to warehouse. Bill Binder had a major plant in Denver and warehouse in East Denver. The road network with time in minutes is shown below. Pass 1. Our objective is to minimize time taken between node 1 and node 10. Pass 2. Constraints are given below. Net flow from starting node 1 is 1 and net flow to end node 10 is 1. For rest of the nodes, net flow is 0. Part 3. Next process to solving the problem using QM for Windows. Part 4. We put the data of the problem to QM for Windows and it gives us the respective solution of the case.
Solution, we found that the shortest path is from node 1 to node 2, it takes 20 minutes. From node 2 to node 4, it takes 5 minutes. From node 4 to node 8, it takes 10 minutes. From node 8 to node 9, it takes 10 minutes. That is to say, traveling from plant along North Street up to highway up exit 135 and going forward. It through exit 135
6 up to exit 137 from exit 137 warehouse along South Avenue. The solution that we found is that the shortest path takes 16 minutes.